That friendly lady.
Should we start a new one right now as
I
you
would
build
recommend that.
one?
Yeah. That way you can, again, play with your existing one over the break. So I will warn everybody that there's a good chance tonight could be a slightly longer than normal class. So if anyone needs to go up because they have work tomorrow, something like that, just give us a heads up in the chat and you can head out. No matter what, I will be recording until we finish. So you'll be able to catch up on that if you have to leave a little earlier. So there's a chance it could go later, but I think we'd be able to do it. We do think we can finish it within the time available. But like I said, if you need to get out because it's getting a little late, go for it. 12 dash drink dispenser. All right. I called mine 12 drink dispensers, so because it's for cohort 12. That's clear. First thing I'm going to do is I'm going to do my get my initial commit out there. So commit. What do I do?
What?
Right. Yeah, doing commit.
Before you added, you did an init, right?
Yep, I did nothing else. I just
Okay,
didn't
all right.
add
That was the part.
the git commit. So I did the git add to add all the default files that are pre-built. And I committed it, and that's all I'm going to do locally. I'll actually create the remote repo more near the end. So at least I have my initial commit now. All right. All my files, we can see them. Now let's head over and bring over the assignment again. Anyway, here we go. So again, and the main thing we have was the drink dispenser, cup holder, shots, and syrup class. We had 4 classes that were very obvious. Could there be more? Yes. Could there be less? Yes. But we definitely could see that there was at least it was very obvious there seemed to be 4 obvious ones. Drink dispenser, syrup, shot, cup holder. So drink dispenser definitely requires syrups, shots, and cup holders. So probably save that one for last. And I just got figured I want to do syrup, shots, or cup holders first. Well, if I wanted to, we could just go in order based on what the assignment is, cup holder. Or also one of the simpler ones, potentially. But let's start with there. And there's Titus. I wonder if he's going to pop in. Hello, Titus. Oh, we have to connect his audio, but hello.
Hello.
Cool. And yes, we're already recording, just so you know, Titus. I got it going already. I actually got several others who are willing to remind me, so you're good.
Awesome.
Yeah. All right. So the first thing I'm going to build is the cup holder class. Let's go ahead and do new class. New cup holder. Again, for this project, I'm not going to add automatically because I want to keep practicing the git commands. And so according to the details, there was a volume per cup and quantity. And so those were the 2 main things we needed for this. So let's go start with that. Oops, not P, capital P. Vol. And for those of you who typed volume, that's fine. I'm used to vol being volume, so I'm okay with VOL. If anyone here wants me to use the full typed out one, I am more than willing to do that. But if everyone's okay with vol, we can move on with that. I'm just very used to using vol for volume. It's a known abbreviation in my mind because of math classes I used to take. We then have our quantity, how many each individual cup we have for that cup holder. How many cups is that cup holder holding of that quantity, of that volume? And so for me, again, I'm going to use the QTY abbreviation, another abbreviation that is usual because quantity is a word that very quickly becomes hard to read. It's like one of those words, what was it, animal yesterday? If you guys typed animal enough, it became hard to recognize. Quantity for me is another one of those words that does that very quickly. It looks wrong every time I spell it.
That's how I feel with the word served right now.
Which one? Serve? Syrup. Oh, yeah. Oh, yeah. That one. That's probably going to be one of those. Yep.
That was a borderline fake word anyway. Look at the way it's spelled.
It is an annoying word. I actually had to double check myself. I'm like, is that where the Y goes?
Yeah, I did too.
Like, am I right on this? I questioned myself with that word. I do not like the word syrup. So let's see, we got that. So there's our volume per cup. And then our quantity of cups we have available to us. Our cups are not smart, that's fine. We need but that's not really a method, it's just a note to keep track of our head that we don't need this information. We do need a dispense cup method, so let's build that next. I don't know what the return type is yet if I'm just reading it from right to left, so I'm just gonna do void to start. So this is something that could be a good practice to do. Until you know what you're returning, go ahead, you can of course read to find out, but if you're not clear right away, you can write void to start, and then as soon as you realize, oh, I need to return this, then you can update it. So I'll start with void dispense cup. As I read the system, it will return the volume of the cup. Oh, there we go. I now know the return. So the volume of the cup, oh, that's an int. Let's switch that to int. And return vol. What else does it do? And it's going to deduct 1 from its quantity of cups. All right, well, I can come back and do QTY minus minus. That look good?
What? So can we just go over why didn't we use void again, just so I can get that concept down?
Why is this yelling at me? Oh, because I've never used. What's that? So one more time.
Can we go over this dispense cup method? Why aren't we just is this going to be, why aren't we just making our, just kind of going over why we did this?
Just, you know, the inspiration of this, if you if you have been to a more modern McDonald's recently, or even a Burger King or a Wendy's, they now have these automatic fountain machines.
Oh yeah, okay.
Goes up, they hit the button, the size and the drink they want, and a cup holder actually drops the drink into a conveyor belt. So they don't even pick the drink themselves. They don't even pick the cup themselves. When they pick the size, that cup falls down. And so that's what this is right here. This cup holder is going to dispense a cup when it gets the signal to dispense it. It's going to drop a cup into the conveyor.
Oh, I got you. Okay.
Yeah, there would be so be aware that, yeah, there would be additional code in here in the actual system to say, hey, release a cup. We're assuming that that's actually happening. We didn't put any sort of logic that would say pull away the arms so that a cup falls down, or rotate the tires to pull a cup out. So be aware that this we are still playing in the realm of the virtual world, not the physical world, because we aren't keeping all those more exact items in there. But that's the idea here. We're playing around with the idea, and that's why I said the next time you go to McDonald's, now you can look at me like I have an idea how you kind of work. We definitely didn't get into a lot of the mechanical stuff, but the logic we're starting to understand. So we get to a dispense cup, and then the next thing we needed was the 5th star, a refill method. So public, again, we don't know if there's a return, right? If I just read that, a return amount, sorry, a refill amount method. Just reading that alone, I don't know the return type yet, so I'll start with void. And I will then do refill. And we want an amount. Amount sounds like a number, so we'll start with int. And then I could always just write amount first and then read on to figure out what type it is. We'll start with int. And this is going to add amount to the quantity of cups. Well, in order to add to the quantity, it needs to be a number data type. So I'm going to use int because I'm not going to add a half cup, right? I'm only going to be adding full cups. So int definitely is confirmed now. And we will do QTY plus equal amount. That look good?
Um,
Go for it, Titus.
and this is where I'm just going over. As we're doing this, I'm just reading over like the prompt in real time. I got you. Why didn't we declare? You see how in our dispense cup method we have as a public int. Why do we have this one as a void? Is it because we're declaring the amount in the parameter?
Hasn't changed it yet.
On line 12.
I'm not sure what you mean. Wait.
Well, it's a void
Void.
when there's not a return.
Right. And this isn't giving anything back. This is just adding some items to our number of cups. So imagine like this is you just reaching up, adding more cups into your system. And then you're just telling the system, oh, we added 10 cups. So that's kind of the idea here. And that's what I picture would happen in the McDonald's is one of the people would go over, they take out one of the stacks out that has 20 cups in it. They throw it in, they would just tell the system, hey, we added 20 cups to you. And that's even if the fountain system at McDonald's actually keeps track of how many cups. There's a possibility that the fountain machine at McDonald's doesn't count the cups. It'll just keep trying, and then if you don't put any in, it'll try to dispense a cup even though it's not there. So there's always a chance that in the McDonald's system, they don't track it. But this is what I came up with because it just seemed like a good, because I wanted more than one method. Yeah, this one does return something. It returns the volume of the cups. We know how much liquid it needs. This one though doesn't return anything because it's like, hey, we just added more cups. I'm going to save the challenges for the end of the class. So that way we don't go too deep into more of the fancier, more difficult stuff until later on. So that way, if you guys want to watch this later, want to watch the extra challenges later, you can see how those work out later after you get the basic stuff working. All right. So we,
Should these methods and integers, should they be static?
so and that was part of the challenges. So this is something that we did, that I did point out that this one could be, they can't be static because these are going to be instantiated. So some of the, we definitely are going to instantiate these items. So they're going to be different each time. So volume wouldn't be static, but you could argue it could be final. That once we start putting in 15-ounce cups, that cup holder can only hold 15-ounce cups. It can't hold any other cup size. So that's something you could argue. But again, you'll notice what I mentioned inside of the extra challenges, that stuff we'll get into later. So right now I'm going to keep things very basic and simple with just public versus make most things public and stay within the extra challenges till after everything works. Make sense?
Why didn't you create a constructor for this? Isn't this just technically an object that has?
Good point. I was wondering if we're going to get that. So yeah, we don't have that. We didn't build a constructor. Like I said, in this challenge, I didn't want to give you guys the constructors here. I wanted to see if you could argue what items in here need to be part of a constructor. What items, and when I instantiate this, when I do new cup holder, are there values that should be defined during that instantiation? So should volume and quantity be filled at instantiation? When I bring that cup holder into an existence, right? We can do that. So let's do public cup holder. And then what items, when I bring this cup holder into existence, what fields can be defined at instantiation?
Volume and our quantity.
So you're thinking both, right? But I'm going to actually throw a little wrench in that for a second. When I bring this thing into existence, does it automatically come into existence with cups in it?
No. Oh,
There you go. I like that. Yeah. No, not necessarily, right? I can always instantiate, then refill and give it a starting value, right? Of how many cups. When I bring this thing into existence, it's going to, you could argue that this is being brought into existence at the factory at a certain size, and then it gets sent, added to the drink machine, and then someone's going to refill it then. So it's not, now can I make a constructor that will take a certain starting value of cups? Of course I can. We're in the virtual world. We aren't bound by the rules of the universe. So if I wanted to have this thing pop into existence with cups pre-filled, I can definitely do that. But I wanted to kind of give you that idea of like thinking like, oh wait, I don't have to have a constructor that does both volume and quantity because I can always refill to get the quantity to a certain point.
so if you didn't want to use it on the, yeah, I was about to, that's exactly what I was about to ask. Perfect. Thank you.
We can have quantity start at 0 whenever we bring it into existence and then refill it right away. At the same time, I could always create an overloaded constructor that'll take a volume and quantity to pre-fill both. But for the moment, we're going to do this one just to have something a little different here. This dot val equals vol. Sound good? If you have a cup holder int vol int quantity, you're fine. Don't be upset with it. It's fine. It works. It's good. Because again, I want to kind of challenge you guys to think like, oh wait, I didn't need to do quantity. I have a refill system that I could run as soon as I instantiate. Right. So something to consider.
I screwed this up royally.
What part of this did you not get?
Because based on a conversation you had with somebody in the room, I started thinking, oh, I need a size small, size medium, so all these different sizes in this.
Yep. I was worried about that because I had a conversation with one student that was hinting towards that. And I don't remember who it was now, but I didn't want to over sit on it and get more people confused, but I was like, did I confuse people? I wasn't sure. I should have touched base on it more. I'm sorry. I should have covered it.
No, it's not your fault. It's my own
I
fault. I
saw-
had something similar to this. I was like, wait a minute, I gotta account for the small, the medium, and the large, and the quantity, and like I went off the deep end.
I thought of that as well.
I saw it was it was part of the homework, so I thought that that should be included too. So,
Possibly clarify it a bit more. I tried to push it a bit with that third item in the drink dispenser system we'll have, saying 3 different cup holders. And you trying to, that you're gonna have 3 instances of the cup holder class, 1 instance for small, 1 instance for medium, 1 instance for large. I wasn't sure how to get that there because I knew that could be a confusion, but it's fine. If you did build a single cup holder that can track all 3 items, that is fine. Your code is going to be very different from what we built. You can definitely have a tri cup holder. It's not going to break your system at all. So that just, yeah, you'll have to have a ball.
I was thinking, oh, I need to know the quantities of the small, the quantities of the medium, the quantities of the
Yeah, we're
large.
gonna do that. Yeah, we're gonna do that with 3 different cup holders. But
Yeah.
no, what you built is not wrong. It's just a different way of doing it. And this is one of the ways I want to show you another way you could do it, where each cup holder has its own quantity, its own value.
Sure.
Yeah, that's what you explained to me, because I thought about putting 3 different cup sizes, and you said, well, you can just
Cup
get
holder.
to 1
Yep.
cup holder with 3 different sizes. I'm like, okay.
One of the difficulties as a teacher is how do I make sure to
part into it.
clarify what I want without giving away what I want?
Yeah.
And that's a difficult
I
part of a
get that.
teacher's role, is being able to say, this is what I want without telling you, do this. It can be tricky. So, yeah, trust me, everyone, as you can tell now, as you can see, you aren't the only one who thought that. So that's fine. Okay, so we got our cup holder. This should do everything we need except for the extra challenges. So we're gonna keep this as is. And then we're gonna move on to, I'm gonna start us with the syrup details. I actually didn't realize I put shots first. I meant to do syrup first. My bad. Because again, one of the things I meant to mention, but I was eating away our time, was that because of how the system's defined, you could start with just the syrup system and add the shot system later. Later. And so we're going to do that. We're actually going to see how that would work. So let's go ahead and add the syrup system first and get our system to create standard, everyday, simple Cokes, Sprites, and Dr. Peppers.
Ooh.
So no shots yet, no vanilla, no cherry yet. We're going to start with the simple syrup thing with none of these fancy flavor additives for in the beginning. Save ourselves a little headache. So new Java class. We'll call it a syrup class. Onward. The syrup class, this is if anyone's ever worked at a fast food shop before, or even a restaurant that has fountain drinks. For me, they were boxes that had a bag inside of them. And then you would just screw on the tube and it all went into the ceiling over to the fountain system. And so that's what I'm figuring here. To an extent though, I realized that what we didn't do any sort of math where we're using a certain amount of syrup versus and adding in some CO2 water. I'm actually taking out exactly the amount of syrup we need to fill the jar. So just filling a jar full of syrup. Didn't realize that, but I didn't want to overcomplicate it. So we're gonna say these are already diluted syrups. So pre-diluted syrups, and all we're doing is adding in some CO2. It works. It gets the point across. So first thing we need is a name. So that'll be a string name.
When we
Public.
aren't we extending cup holder class?
Is that Titus?
Are we extending the cup holder class?
Are syrups a cup?
No, but what isn't it that system? Wouldn't that system be using
Again, remember, inheritance follows an is-a relationship, right?
Right.
So syrup doesn't have a volume or a quantity, does it? Because if we extend the cup holder class, it would gain those properties, wouldn't it?
Yes.
And our syrup doesn't have a quantity or a volume, does it?
Mm.
So those are the questions you want to ask, whether or not something should be inherited or extending. Can I say is-a? So is syrup is a cup holder, and that doesn't make sense. And then syrup should it have the properties, the fields and methods of the parent class that I'm extending. It should not have a dispense cup method. Syrup should not have a refill method. Well, maybe it does, but not the refill cup method. And it shouldn't have the quantity or volume. So it's definitely not a child. Make sense?
Makes sense.
Cool.
Can I see your cup holder class real quick, please?
Of course. I'm also going to put my headphones on in case there's some feedback. I just realized I didn't have my headphones on. I don't know if you guys are hearing yourself. Where are my headphones? Oh, they are. Go for it. Ask your question.
I was just saying if I could see a cup holder cost.
Oh, sorry. Yes, I just realized I did kind of close that kind of fast, didn't I?
Robo Simer activate.
There we go.
Thank
I'm gonna shrink this a bit so we have more
Just
space.
a, well,
Why did it open up so wide? I don't
just
know.
a question. On the cup holder,
There we go. I can see now. I can hear everybody now. All right. All good?
can you hear me?
I can hear.
Okay. Just on the cup holder, I realize what you were saying about instantiating those, but can you also add? Would it be also possible or a good practice to add a size, is like a string size? Because you could say cup holder, you know, volume, quantity. I have like 5 8-ounce small cups.
You could. That's something to argue. Definitely something you could add. I'm not going to add it for this one for the moment, just because I want to try to build where we were trying to build this one, so you can see what the end result was. My goal was.
Yeah.
But yeah, definitely something you could do. The reason why I don't want to do it is because we already are returning the volume in the cup holder. Which where did my int go? Not sure. Oh no, never mind. And dispense cup, we're already returning an int, and it's difficult to return more than one property in a method. And we're not going to get into that complicated system where we're returning more than one thing.
Yeah.
So that's all.
All right.
Sound good?
Yeah.
Cool. Yeah, the idea is that the cup holder doesn't know what size it is; it just knows its volume, and the dispenser, the drink dispenser, is what identifies this cup holder as the small cup holder, this one as the medium, and this one as the large. And that way, anytime if I want to realize, you know what, our sizes aren't good, our people aren't liking them, I'm going to make the medium small, the large is now medium, and I'm going to instantiate a new cup holder that is now the new large, and I'm going to dump the old small. That makes sense? Cool. And that was my thought process. Kind of. I just realized that actually works. Part of this, I will also say sometimes with my thought process, I'm realizing why some of the additional reasons behind what I did, the way I did it, is that I realized, oh, I was thinking of this. I didn't realize I was thinking like that, but I realize it now. So I realize the more and more I say this was my intention, like people are thinking like, oh, he's probably been thinking about this for days. No, I came up with this last night before going to bed. So I changed my what we were going to build today last night and finalized it today. So I didn't spend hours on this coming up with it. So that's why I did warn that there could be some things missing. That's why I tell you guys, ask questions, because I could have mistyped things, missed things, forgot things. 100% ask questions. Excuse me, syrup. We got our name. We need an amount of liquid that is in this syrup bag. So we got public. We'll do int. For those who did double, that's fine. I just want to do simple math for this. I'm going to go with int for myself because I want to keep the math very, very basic. Int.
Is volume to make it
We
easy?
can do volume again. We can do volume. We could go amount. What do we think?
Take
We
it
could
to
technically
a
go quantity, but what are we thinking?
I like volume.
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 All right.
Yeah.
I like it. And then for that, I think that was it for the values. We have the name of the drink and how much liquid. And then we have a dispense amount method. So you got public. See, and so
Not to disrupt your flow. Why?
okay.
Why are you skipping over the constructor?
Again, because I didn't put that in the requirements. So I figured I would follow what most of you guys might have done by
Okay.
going through all the fields and methods first and then do the constructor last, because I didn't define constructors inside of the assignment. So I'm trying to replicate some of your flow, what I imagine some of you guys might have gone through, which would be following very aggressively the instructions of building the fields, then building the methods, and then maybe realizing later, oh, I need a constructor.
It's just weird because like I'm like, what is he doing? Like,
Yeah, I always
Man.
start with the constructor and then
always
go
started
down.
constructor,
Which is fine, yeah. And it is a habit I tend to do, but I can also skip it if I need to, if I don't know what my constructor is going to be right away. And I have certain methods in mind that I know I need to build. I can skip the constructor and build it later.
The only reason I said I had a class, I had a,
Yeah.
not a class, a question that piggybacked off our last constructor. So it looks like this one, instead of our item starting at 0, it would start at full. So we include both these items in our
Yes.
constructor.
Very true. Yep. Now this one makes more sense to be full automatically. When I bring this item into the store and put it into my inventory, in the store inventory, yes, it's already going to have a name on it and it's going to be already full of liquid. So this is something that we're not refilling. This is something that has liquid in it when we get it. So yes, 100% different from the cup holder in that fact. So we'll do that next, actually. And yeah, now you can see where, yeah, this one makes perfect sense to set both. We're gonna get them full already. The cup dispenser is gonna come in without cups. We're gonna have to fill the cups in later. It would be a really inefficient system if we keep getting cup holders full of cups, and every time we need more cups, we have to throw a cup holder out, a cup dispenser out. So I don't like that idea. That sounds like a horrible system. Very
Cup holders
wasteful.
by Apple.
All right, so there's our constructor. So the first method we have was the dispense method. So you got public dispense. Yeah. And at first glance, when I first read this public dispense amount, it sounds like I'm going to do an int. I would think like I'm going to return the amount of liquid I dispensed, right? And so for those of you who might have done that, that's fine. Don't panic with your items right away when building the definition. Just make sure that before you start building your logic, do read your instruction and realize what you do want to return. So we're going to do that in amount. And when I go back and I read the line again, that deducts the liquid from a single shot. Oh, sorry, wrong one. That deducts the amount of liquid requested and returns the drink name. Oh, okay, wait, I'm not returning the amount I dispensed, or the remaining amount, because actually now that I think about it, it would be weird to dispense the amount that I dispensed because I was asked for that amount. So why would I return what I got? So now that I'm thinking about it, it makes a little more sense that this makes no sense, because it's going to ask me, hey, dispense 10 ounces. Why would I then return 10, right? So there we go. So now in this case, we're going to return a string. In this case, we're going to deduct amount from volume. So vol minus equal amount. And return name. Seem good? That's you to do what it's requesting.
Why are we returning the name?
So
Yeah, string.
yeah, so this was one thing that I kind of thought ahead on. I actually was originally not going to have this return anything. This is going to be a void. And then it dawned on me again that later on in our drink dispenser system, we're going to ask for the index number for the flavor, not actually the flavor by name.
Mhm.
And so what happens is that when we ask for it, it's going to return the name so that we can display the name with what we got.
Oh,
And at the same time, I also thought in the future, if we did want to have our system be able to say, hey, this is empty, or I don't have enough liquid, I could instead return null saying, hey, I can't dispense this drink.
interesting. I've
Mhm.
in the dispenser class, I made some new methods that would print out each index of the array lists and I called that the
Hmm.
menu. So you could actually see
There you
what was
go.
available, and then you could pick the indexes from that.
Very nice. Cool.
Okay, so now I see why the name's there. Got it.
Yep, that was my thought. Again, this is just, as I wrote it out, I actually went back to this one and updated it to return the name. So, yep. The next method we had was a get volume method. So we know how much is still in there. So we have a public int vol. Nice and simple, that one. This one is what we like to call a getter. I will say that in this situation, it really isn't necessary because right now vol is public. But I will remind you guys that in the extra challenges for syrup, we do have the challenge to make these values private. And so we would need this get vol method in order to be able to know what our volume is, how much leftover liquid we have left. So this was me prefixing it to kind of get ready for turning things private.
Sure.
There's that. And I think that was all we needed for the syrup item. Yeah, we have a syrup dispenser and get vol, just so we know if it's how close it is to empty. So again, we're going to skip the shot system for the moment, because we at least can maybe start serving simple drinks. We can start with that. So let's build out our drink dispenser now. So new class. And I'll once I get it started, I'll pause for a second and let everybody catch up on syrup. So drink dispenser. I'm going to pause for a second, bring up syrup, and give everybody a second to catch up on here.
The prompt that comes up from GitHub when you create a new class, you said that you don't like to add right? It's not. a
I'm
good
saying no to
practice.
that. Just yeah, I'm saying no to that to keep practicing the terminal stuff. But yeah, and if you are confident in using git add, git commit, and git push, you can definitely take advantage of the shortcuts. But for a lot of you guys, I would recommend for at least the next like 5 or 10 projects to not use that tool for the moment, so you get used to the git commands in the terminal.
Okay. So
That
just-
only
just
comes
pick
up
one.
if you init before you start creating classes, right?
I actually don't know. I haven't actually.
I haven't encountered that yet, and I think that's
Oh,
because
cool.
I only init once I'm ready with all my stuff to then upload it to GitHub.
I see what
Possibly.
it's doing.
Once
Yeah, it's
the-
just
Once the local repository exists, you can use the shortcuts, I believe.
That
Yeah.
makes sense.
For some reason, mine kept saying, anytime that I create a class, it said, "Would you like to add the class to GitHub?"
I think it's whenever you create a new file in your program.
Yeah.
After
Yeah.
you get a init, and the next time you add a file, it's going to ask you. And unless you click the do not ask me again or remember, whatever it is going to keep asking anytime you create a new file. So definitely remember your behavior. And I will say it's repository specific, which since it's going to be you're creating a new repository each project, it'll be project based. Each setting you set is for each project. So yes, every project you will have to tell the system don't add automatically or to add automatically. So it doesn't save globally. It saves per repo, per project in this case. Anybody need any more time on syrup?
Oh.
All right. Drink dispenser, here we are. So if we look back at the drink dispenser details, the method. So first we got to go into the top and see the dispenser system. So we have a collection of syrups. Those we did build. And it's a collection. What's a collection in Java that we can use?
Array list.
Yeah, lists, right? Array list, yep. List, and we're gonna do this, it enters, so it brings in the import. And do syrup. Syrups.
Our collection already built because it's in that class. So basically when you just called list and that popped up, so syrup or cup holder, those could be used in our collection, correct? Mike got that logic down?
Not sure that, I don't think the words lined up right.
So if you went back up, so if you go back to list, like when you typed in list, you said like anything that's a collection. It's not like we already made a list. So essentially our collection right now, the data that we could put in our list is our class. The data from
Yes.
okay.
Yep.
That's what
We're just saying a collection of something. And so we need to be able to store a collection, and we have multiple tools for that. Arrays are a way to store collections. Lists are a way to store collections.
So in the list, we're essentially storing all the data of that syrup class.
No, of multiple syrups. That's the idea. We have multiple instances or multiple items.
Okay.
That's a collection. A collection is just imagine a collection in real life. If you have a collection of cars, you have multiple cars, right? And I was totally thinking hot cars in my head, not Hot Wheels, not actual cars in a garage, just for the record. Not that wealthy. Totally had Hot Wheels in my head. Totally had Hot Wheels.
Only in my mind do I have a fleet of DeLoreans parked outside.
That's your car of choice, a DeLorean.
I saw Back to the Future at 10 years old, and I've never been the same since.
I can understand that.
That's why I play guitar.
Oh, no way.
Yeah.
That's awesome. That's why I am the scooter.
I think you kind of
Kid.
hit the nail on the hammer. I think I was just trying to really reinforce that concept of list.
Yeah. Yeah, like I said, yeah,
And
list is
the
just
Serp
yeah.
could be like object or string. It's
Yep.
just like the data type.
Yep. Yeah, list is just a list of multiple of X, and X is what's here. And so a list just allows you to store multiple of something. And so in this case, we're going to say we're going to have a collection or multiple syrups, and that we can store that we can then reference them inside this list of them. So we can add multiple syrups.
Yeah.
We're going to create 3 cup holders. And so again, there's multiple ways you could do this. You could again create another list. You could also create an array with 3 items. For this, I'm going to keep it very, very simple. I'm going to do cup holder, small, holder, medium, and cup holder, large. Now, what
I
I'm
have a
also gonna do
question
is
about
I'm
line
just getting,
search.
I gotta ask a question. How are you accessing the cup holder class without calling it?
it's right here. It's in the same package. That's getting ahead of yourself. Yeah, we're not doing package stuff yet, so don't worry about that.
I got you. Okay.
Yep.
All
And
right.
also before.
On
So
line
Cliff, you don't have
six-
to write equals new array list or anything like that?
Yeah, that's what I was about to ask. I expected list syrup equals new array list.
Right. No, that's a good question to ask. And again, that's something we need to decide. Is that going to, are we going to instantiate the list in the constructor, or do we instantiate the list here? And so does anyone have any ideas of why it might be beneficial to do it in the constructor versus here? Are there any benefits?
Don't even know what it looks like in the constructor.
Oh, same command. We just wouldn't accept it as a parameter. So for example, we could do,
I would say maybe just of the scope of it, from just the global scope of the nature of where we're declaring it, if I had to guess.
we could just do that, and that's allowed. So we could do the new array list in the constructor. We don't have to accept a parameter for it, because we can just leave it blank. But we could instantiate the array list at instantiation here. We can also do it here. Now, this is something that I will admit, it might be because I think it's in like Objective-C or somewhere. You can recall the constructor on an already instantiated object. So when you bring something into existence, so I bring this cup into existence, I believe it's C#, I can do this. I can reinstantiate this same exact cup and run the constructor on it again and have it reset itself. I don't know if Java allows you to do that, to be honest. So in this case, this may not be any difference. Whichever way you did it, if you do it like this, or you put it here, your behavior is going to be the same in Java. The only way the difference is if you can rerun the constructor, that would reset. If you have it like this, it's not going to reset your list. Your list would not reset if you rerun the constructor. If you have this version, anytime you reinstantiate the object, you will reset your list, because it's going to run this line on every construction. Does that make sense?
Yeah.
So that would be
Okay.
a bad thing, right, Cliff?
Potentially, yeah. So, we can put that here.
Okay.
This is fine. This will totally do what we want it to do. What I was hoping to do there is just showcase that either way, you're going to work. So whether you did it here or you did it in your constructor, doesn't matter. It's going to work the same. All right. And I'll just put that in comments. We're gonna... Either way you put it, it will work the same. Sound good?
Yes.
Cool. Now in this case, I am going to do one thing where I'm actually going to allow our drink dispenser in constructor to accept its 3 sizes for strings. So when I instantiate the drink dispenser, I'm going to get my 3 sizes. So int small, int medium, int med, and we'll even do SM. And it's int SM, int med, int LG. So I'll do here is I'll do small equals cup holder. Small.
Oh, interesting.
You have to write out the whole. Is it not going to yell at you if you do like SM, or why is that?
Well, again, that was just because it's not a this.small equals small, so I wanted to give you guys that that differentiation. In that case, I have to do this small equals small, like this. So again, if that looks better for you, go for it. But this is different than our normal this.x equals x that you guys are used to seeing. So since it wasn't the same, I figured maybe we use different variables. But if this makes more sense to you, that's fine. What do you guys think?
I
We like
don't
the-
even know what I'm looking at right now.
Right.
Yeah,
That's
I'm
why I
kind of
was thinking-
confused from going one way of doing it to the
Yeah.
next.
Yeah.
Well, this is what I'm actually doing. So here, I'll do this quick so we can see what these are actually storing. So what I'm actually getting is the volume of the small cups, the medium volume, and the large volume. So I can create 3 cup holders that are going to accept cups of different volumes. And so this is going to be so small equals small
Oh,
valve.
you're making them all at once.
Yep. I'm bringing into existence.
Ah.
So this drink dispenser is going to come from the factory with 3 drink dispensers attached to it. Because if you noticed in my drink dispenser details, I never put a add dispenser method, did I?
No,
So where were you going to put how are you going to create these drink dispensers?
I instantiated them in the main class separately.
Yeah, and then they wouldn't be part of the drink dispenser though, then would they?
I
Nope.
instantiated them up top in the drink dispenser
Yeah.
class.
Yeah, this was going to be the challenging one to see where you guys went with this one. Because I was leaving out the construction like, oh, this is going to be difficult for them. I'm not telling them to instantiate the cup holders. Where are they going to do this? So I was curious to see what you guys did with this.
So we were set up.
Kind of, yeah. You could definitely argue it. I could see you guys arguing it.
Code was rigged from the start.
And part of me, I do want to do that because when you get into companies, you're not always going to get perfect instruction. You're going to get vague instruction. And so being creative and just getting it work is a good skill to have as a developer. So being creative, being innovative and trying to work around not full code. Hell, even some of the first couple cohorts we used to do, some of the first lessons we used to give our students were actually outdated lesson plans. And we did that on purpose so that they would get error messages and have to go find the updated code.
Oh, you guys were cruel.
Yeah. So be happy where you are. Yeah, we would purposely make sure that we would actually perfectly fine giving some of the students a lesson that was a year and a half old that had, it really only had like 2 lines that were outdated because the language wasn't that, it was kind of old, so it wasn't updating that much. But there just was 2 lines of code in the curriculum that were old and outdated and deprecated. So they had to go find the updated version of that line of code. Yep. Because that's going to happen to you in the real world. You're going to need to learn something and you're going to have struggle finding the most up-to-date version of stuff sometimes.
That actually happened with one of the hacker rank challenges. It gave us the correct formula.
Yeah, I can see that. Yeah, it's a good skill to know, to be able to realize, oh, this is not working, it's out of date. I got to find a correction to it.
I got to get back to those. I'm stuck on day 9.
I was actually, go ahead.
So just to be clear, this is the preferred method, instantiating within the constructor, because I did what Matt did. I just created the cup holders in main and then passed it on to the constructor.
Ah, okay.
Or
So
at
you
least
actually,
that's what I think Matt did.
That's it. Yeah, that's exactly what I did.
Okay.
So
Well, yeah.
whenever it gets, I create the cup holders first, and then whenever I'm creating
So
the
that-
drink dispenser, I'm gonna.
I would argue that there's another thing where you could have done this. You could have done this as cup holder small, cup holder medium, cup holder large.
Yeah, yeah.
As
that's
long
what I-
as you
Yes.
did, yeah, as long as you did the inline instantiation like we did in the one on Tuesday. If you instantiated them into variables in main and then pass that variable, that means you have a way of access. That means main can access the cup holder directly.
Okay.
So that means
And we
when you
don't
do
want that, right?
let's see, when you did new drink dispenser like this, you would do new cup holder. Yeah. Right. As long as you do the instantiation of the cup holder as a parameter,
Okay, no, I
instead
did
of
not do
doing,
that.
yeah, you create a cup holder out here. That means that main now has direct access to that cup holder that belongs to the drink dispenser. That makes sense?
Yeah.
Yep. And our idea is that we want to be able to we want to access the cup holders through the drink dispenser.
In my mind, they were modular and they were getting installed as the main dispenser came into the shop.
Ooh, actually, you know what? You could argue that because technically you don't need to access the drink dispenser to refill them. Huh. What you built is not, I can actually say you could have an argument of what you built is not wrong because you shouldn't, you wouldn't technically have to access the drink dispenser to refill the cup holder. You can refill the cup holder on its own without the drink dispenser. So you could argue your setup that main should have access to it. So yeah, I won't say it's wrong. Just not my envision. Yeah. Yep. What you built can be used and can be argued. And that can be a very fun thing to do also during interviews and stuff like that. When if an interviewer ever asks you, why did you do X instead of Y? As people, we tend to panic thinking we did something wrong.
No, just
Thinking that, yeah, we think that Y is the right thing we should have done. In computer science, that's not always the case. In computer science, that's just the way they envision doing it, and they are genuinely asking you, why do you do it that way? And so all you ever want to do is just justify and explain why you did it. Actually give the real answer as to why you did what you did. And a lot of times that just will actually, it can even impress the interviewer. What was his name? I think his name was Josh. And we actually had him go to an interview. He failed the first time. He came back. They're like, he needs a little more time. So we had him sit down. We had him work a little more. Goes into the same company for a second time to interview. Solves a problem in such a unique way that they actually took his answer around to other developers. Like, hey, take a look at how this guy solved this. I'm like, that's interesting. I never would have thought to solve it like that. He ended up getting hired as a team lead because he had managerial he actually had some managerial experience in his past. He hadn't asked for it because of how he answered this one so uniquely and had that managerial past. They decided to hire him on as a team lead. And again, this is someone they said no to the first interview. So I will definitely say that too. Yeah, if you ever do get a no at one of the interviews we work with you on, most of the time when we work with the companies with you, their no is just a not yet, not a never. It is a not yet. They need a little more time in the oven kind of thing. So when we send you to the interview, if they say no, that doesn't mean you're done. That doesn't mean you did horrible. Which means you may have that they didn't see what they meant that we wanted them to see that time usually, and they know that. So they just say, "Oh, well, have them practice a little more and have them come back." Usually, yeah. Ever get asked, "I did it this way." Never think your way is wrong. Be ready to just explain why you did what you did. Sound good?
Mm-hmm.
Cool. So we got this. Now we have a drink dispenser. And yeah, that was what the properties are for the drink dispenser that we are doing right now. So we're not going to do the shots yet. So we have our syrups. We have our 3 cup holders. We constructed it and created the three cup holders. And actually, now that I think about it, there is no way you guys would have thought to do it this way. I just realized because you guys don't know how to access a class inside of another class to be able to access the refill method. Didn't think of that. Since they are public, you can, so it's fine. But yeah, I'm less surprised that you did it that way because yeah, you may not have thought of doing drink dispenser .small .refill. Then you guys would have thought to do that possibly. So
I think I did that on. Oh, because I did that for accessing some of the stuff from the array list.
Ah, okay. Yeah, you would just access the drink dispenser one of the properties, and then you can access its methods too. But it's fine. Let's keep going. What methods can we build right now? Well, we can build the first one, the serve drink size and syrup index. We have our sizes and we have our syrup index. So we can do public drink size and SY index, yeah, SYI, syrup index. I don't want to keep typing syrup. Screw it. Syrup I. There we go. That's an int. And return type, don't know yet, so we'll do a void for the moment. All right, so we will get a cup of size requested. So we need to get the cup. So let's do cups. What methods are in the cups again? Let's take a look. So to get a cup, we dispense cup, we're going to get an int. What is the int we're getting when we dispense a cup?
Oh, that is the volume of the cup.
So int vol equals dispense cup. Well, wait, I need to know which one, and I need size. Well, I can't do a variable name equivalence to size. So you know what? I need some sort of conditional. And this is going to be whether or not size is SML, small, medium, large, whatever string I want to use. What's a good conditional tool to use here? What was that?
A switch.
Yeah, switch, right? So we're just saying in the case that size is small, dispense a small one. If the case that it is a medium, dispense medium. In the case that it's large, use a large. So I can use switch in this case. So I'm not checking for greater than or equal to, I'm checking for equality. I'm checking for straight up equality. I'm not looking for less than or greater than. I'm looking for straight up equality. And that's the most common use of a switch case. All your items, just if it's equal to this, do this. If it's equal to that, do that. Else, if it's equal to this, do this. Switch cases don't work on ambiguity or ranges. Switch cases work on one-to-ones. So switch size. We do it like that, right? Yeah.
So if you were to use, instead of string size, if you were to use like cup holder instead of string, wouldn't you be able to access it directly that way?
Only if I have access to that object outside. So the way that like the other guys built it. So what was that? The way that they built it, where they yeah, Matt, I think, right, Matt? Yeah. When Matt built it, where he initialized his cup holder in main and then passed it to drink dispenser, but kept a variable in main that can reference it, then yes, I could pass that through. So the way Matt has his built, he could definitely do that. The way I have mine built, I can't do that because I won't have access to these references here. Outside of I don't have access to these variables outside of drink dispenser, if that makes sense. So I would need to pass exactly this. Oh, maybe I could. Can I do?
I created mine like you did on 8, 9, and 10, except for I just did it completely on that line.
Interesting.
Instead of using a constructor, and I was able to do that with instead of string, I used cup holder.
I think I just thought of a way of doing it, doing drink dispenser dot small, drink dispenser dot large. I could possibly send it then. Huh. I want to do this just so we can show the switch statement.
Okay.
But I didn't think of that. That's a good way of thinking about it. Nice way, and I can. So again, even there, now you can see it. As a teacher, one of the students came up with possibly a better way to do it. So 100%, nice. They thought of that. I didn't think of that. Yeah, I could, but I could send the cup holder by doing drink dispenser dot small, drink dispenser dot medium, drink dispenser dot large. Didn't think of that. Nice thought. Cool.
Thank
All
you.
right. Me, I want to do this. We're just going to do S equals all dot dispense cup. And then and equals medium cup. Break. L. And dispense cup. Nope. Large. Then just as a safety item, it's always good to put in a default, even if you will never hit it. What it's smart to do is just do a S out. Yep. Make sense?
Yep.
So 9 times out of 10, even if you don't have a default behavior, put something in as a catch-all so that your system doesn't crash. Otherwise, if you don't have a default and you try to do it and you do a switch statement that doesn't hit, it can potentially break or have side effects where nothing happens and you can break down the line.
We weren't like, for me, I feel like we saw this a lot when we did Redux, when we had to like, when the same concept, obviously it's not Java, I'm trying to think, but same, I don't even remember Redux anymore, but I remember this concept with the switch statements, then having that catch to basically, as it says, he doesn't fall flat on his face. It's interesting.
Yep. Exactly. And those are just common practices in a lot of languages. Yeah, again, as you deal with more languages, you'll see repetition in these things. So again, this, as most of you are probably realizing this right here, if you did a switch statement in JavaScript, it looks identical.
Yeah.
So, well, there's a lot of familiarity with other languages. Once you learn one, going from one to another can be simple. The biggest challenge in a lot of these is just the changes in the syntax and the way we think about a problem. How do we approach a problem? We approach problems differently in Java than we did in JavaScript. The overall syntax is fairly similar, but the way we approach problems is now changing. That's the biggest hurdle for Java, if you ask me. We got that. So now we have our volume. We have a volume. So we dispense the cup. So we now technically have a cup. Our volume is us holding a cup. We have a cup in our hand that can hold a certain amount of liquid. We now want to dispense the syrup requested from us. So now we're going to go ahead and dispense the liquid, and we want to do syrups dot get syrup I dispense. I'm going to send it. We need to send it an amount. So what am I sending it? How much liquid do we want to? We want to dispense a certain amount of liquid. How much liquid do I want to dispense?
Size, the volume per cup.
Yeah, vol, right?
Oh.
Yeah, which is what we got, right? Vol is storing the amount the cup value we have.
I think it needs to be specific to the size, right?
All right, there's a chance that it might not get right here. Hold on, we'll do that. Sorry. What do you mean? Like it is, because it's vol will equal either large, medium, or small, depending on which one we ask for, right?
Okay, all right, yeah, I just got confused because of how I did it.
Okay.
Oh, I didn't do this part right. Okay.
Can you go over
Yeah.
that syrups that statement one more time? So can you just go over?
Yep, we're gonna grab the syrup at index I. So we're gonna pick the syrup at index I, and then we're gonna dispense the amount based on the cup that we chose. So either the small cup, the medium cup, or the large cup, because either one of those get added to vol. So our vol or volume is equal to the volume of the cup we dispensed. And so we're gonna ask that syrup to dispense that much into the cup. Do we see that?
So for some reason mine is yellow. Let me do it one more time. So syrup index.
Yeah,
Does it matter if it's capital? Oh, make sure it's on my screen real quick.
it's my small that's yelling at me.
Well, let's go ahead and we'll start with Titus. Go ahead and share your screen first, Titus, and then we'll do Junior second. Go ahead, Titus.
It's because you typed it as SERP on line 19.
Yep.
Oh,
Yeah, that's why I added that I to make sure it was clear that we're getting a index, not just a syrup name or a syrup object. So that was why I did syrup I.
and what?
So I did add this, by the way. On line 32, I did a return after that. For the default clause, yeah, I quickly added a return because otherwise there is a chance for our system to hit line 35 without setting vol. Vol could be undefined at that point. There were two ways I could have fixed that. I could either fixed it by returning or by setting vol equal to 0 when I initialized it.
Oh, okay.
Oh, I see what it is. Anyone see the problem?
Is the cap
Small is large on line 14. It's S and small.
24? Yeah, 14 is capitalized.
Oh, so that's why this one is like that.
I would not do it there though, because your small is not a class. So I would actually change your small into small s. And that most likely, if your small, if your s is large there, it's likely large somewhere else.
What?
Scroll up a little bit. Take a look.
Yeah, not line 8.
There it is. Yeah. Yeah, it's a variable, not a class. So we don't want that we don't want that title case.
Yes.
There you go. So now we're just gonna go back to my code so you can then copy down the large and the dispense. So I'll leave my code on screen for a little bit. Stop here for a second. So again, and what I'll do,
Mine's yelling at me.
How's your
Mine's yelling.
dispense working?
Go ahead, Keith.
Line
show it off.
35.
Hold on, Keith's gonna show his next. I gotta stop sharing. Hold on. There you go.
It's okay.
Go ahead, Keith. All right, yep. I should have done this a little. I did this way too fast to people. I have several of you guys miss it. Line 35, I added a return. Oh, line 34, sorry. Add a return.
Oh,
Yeah.
Is the purpose of line 36 basically to kind of like
36, I mean.
is the purpose of that kind of initialize are whenever that's called, that's what's going to run to get that method running?
What do you mean?
So line 35 on your code, is that your code?
Yeah.
It's basically, is that telling it start whatever they pick, we're going to start. It's giving it like a neutral starting point because we don't, when we press the button, we don't know, the computer doesn't know if it's, hey, it's, this person wants a large, this person wants a medium, this person wants a small. It's just saying,
yeah. Well,
idle.
It knows what cup it wants. It just doesn't know how much liquid that cup can hold. Because we're, as we said before, we're kind of looking at our cup holders as modular. We can swap them out. So one day our small could be a 5 ounce, and then next week we say, you know what, small should be a 6 ounce. So we swap them. And so the serve drink doesn't care how much a small is. It just knows, oh, if I get told to do a small, I'm gonna get a small cup, and then the cup dispenser is gonna tell me what size that is, how much liquid that cup can hold. So the cup holder is going to tell the drink dispenser, hey, here's a small cup and here's what it can hold. And that's when, and then of course it dispenses. So that's what's happening. The first section here, this is the system getting a cup and learning, oh, this is how much space the cup has. And this one here says, okay, now that I have my cup and I know how big it is, I'm going to dispense that much liquid into my cup. And so, and everyone, again, just double check that you have this. The reason why we need this, and again, why that was there, is because on volume, we didn't give it a number. And without this, if we hit this line, I didn't have anything. It was still going to run this code. And what the system was telling us is that there was a chance that volume could actually still be undefined, not initialized, because we could have hit this line and then hit this line after. So the return tells it just to end the code, so we don't hit that line without an initializer, without initializing volume. So that's what it was yelling at us for. Another way to fix this would have just been to do vol equals 0. And then we wouldn't need the return anymore, because that way vol would have a value. So there's 2 ways we could have fixed that. We don't actually want to dispense 0. All right, so we got we're dispensing our cup.
I think I gotta go to McDonald's. Because I just remember holding the button down until once the cup is full, then you release the button.
That was the first instance of it. Yeah, that was the first of it. That's what they had when I was there. They had just, you put the cup in and it dispensed, and it was up to you to do it, and then you had to dump and then do it again, then dump and do it again, dump and do it again to get all the bubbles out.
Yeah.
That was
Or
my
you
life
sip
at Burger
it,
King, McDonald's.
You
Yeah.
drink some because it's before free refills. You're like, all right, I'll get a whole bunch in.
Yep. I was talking about me in the behind the counter. I was like, I don't remember drinking it.
Yeah.
Like, I don't drink the customer's drink. I actually worked at Burger King. I actually worked at McDonald's. So, and yeah, but back then we actually had we had to put the cup in and hold it there and then pull it away. Then the next iteration, they had the small, medium, and large buttons. So you put the cup in, you'd hit the button, it would dispense. And then they would still have to pour it out and then hold down the free dispense, just while they hold it, it dispenses. So they did have the 3 sizes, but then they also had the free dispense to fix it or to do custom sizes. So it's an interesting how they've slowly migrated to more and more automated drink dispensing. So it's an interesting thing. And from my understanding, actually, if you really want to get into the nitty gritty of it now, they even have a laser that will detect when the bubbles are at the top, so it stops, wait for the bubbles to go down, then it will dispense more. So it's a fascinating thing, how fancier these things are getting. So they're trying to automate a lot of it that is considered redundant, like just mechanical work for the employees, so they can focus more on the customer service side of it, the customer facing. So, and that's again, what's that?
I was just gonna say I instantiated my drink dispenser called McDougal's, so I guess in a way we are at McDonald's.
There you go. I like it.
I don't mean to interrupt your teaching with my terrible humor.
I was actually gonna make my joke myself, but like
Oh,
that's just
good.
until they actually do eventually automate everybody. Till we have the first robot McDonald's.
Yeah, I feel better about my poor humor now.
All right. Anybody have any more problems with this code so far? All right. have a syrup drink. Now we do need a couple minimum items here to make sure the system works. We're going to do a add syrup. And that's going to take a syrup. And we're just going to do syrups.add new syrup. And so this is one where we're going to instantiate when we send it. So we're going to send it as a new syrup. So when we call the add syrup method, we're going to call add syrup, new syrup. So instantiate there. But again, we could do it here where we do an add syrup, name and volume, and then we instantiate here. So there's two ways we can do it, and I'll show you the other version. Actually, you know what? Just to help you guys out. So void add syrup. Syrups, add syrup. Do you see how the two work differently? So this one will take a syrup that's already instantiated and just add it, where this one will take the syrup's information and then instantiate it for us. So this is just going over to the system and saying, and this would be, so in this example, this would be us just telling the system, hey, there's a new syrup there, go look. It's already attached, it's already connected, and it can communicate. This system is us connecting the box, going over to the system and be like, hey, I added a new Coke with a volume of 400, enter. Sound good?
Mm-hmm.
So you have two versions. You know, I'll keep both. That's an overload. That's a nice overload. So we have two ways of adding syrup. And I'll be able to show you both ways of calling it, how we would call these two methods so you can see the difference.
Can you just hold on that before you move on so I can get that down?
I was waiting. I'm going to look at what I want to do next. So go for it. I'm going to look at. I think we might be ready to go. That's why I'm going to take a look though. I love syrups. Ooh, move that out of the way. Yeah, again, you only need one of these for everyone there. For your code, you only need one of these because just make sure you use the one you implement. If you don't implement both.
Just comment one out, but that's very cool to have. Okay, I'm all set now.
Oh, you don't need to comment them out. Leave them both in. They both they won't break it. Having both in won't break it.
It's yeah.
Yeah, overload.
I'm
different parameters. So
yeah, was very much thinking in the world of JavaScript.
Yep. So I want to say, no, don't you dare comment that out. If you have both, leave them both active. All right, and we'll just we will add. Let's go ahead and do the low. Actually, no, we're not going to do low syrups right now because I want to make this work. This actually can run. We'll add the low syrup after because that's going to be a logical item. That's going to be algorithmic kind of based. So let's just see this system work. I think this is going to help you guys feel a little better about this and kind of see where we were going with it. I'm also wondering for in the future, maybe make a functional one so you guys can kind of see what the output should look like, kind of see some things. I don't know yet, but I'm trying to think how could I better explain what I'm envisioning. But again, it's also at the same time, again, I want to see what you guys build. I'm also curious what you build because I do like some of the different ways some of you guys have been building things. I'm really excited to find out that this was unnecessary, that I can't accept a syrup as the cup holder as a size. So that was actually really cool to find out. Anyway, I think, yeah, I do still think I might have a reason for this later, but again, it's fine. What am I doing? Yes, let's go back to main now. So we're gonna move this over here on main. So what we're gonna do is we're gonna instantiate a drink dispenser. DD. Our drink dispenser DD. Sound good? Or do we have a better name? Do we want to do McDougal's?
Let's do something like, just make it more real world. Cliff's dispenser. How about that?
Sure. I don't like spelling dispenser, but it's fine. Drink dispenser. And so now we need the sizes of our small, medium, and large cups. So what are the sizes of our cups?
You
can go with ounces. It's fine.
5, 10, 15. I don't know.
Sound good, everybody? Nice and simple.
8, 16, 32.
I don't think that's usually how they go. I would think it's more like 5, 8, and 12 would be the more common situation because they usually don't do doubled and then tripled. They're actually usually not doing that in most cup systems.
Well,
Because in this
16
case,
fine.
Or just like half a gallon now.
yeah.
Yes.
There you go.
Like
Mostly because
usually
I
8
also
ounces
want
and
to, I
16
personally
ounces.
want to make sure that at some point that it's less likely that I'm going to perfectly dispense my syrups. I actually don't want that because that's not normal. It's a common situation that I run out of syrup mid-drink. And again, that's kind of what I was kind of doing with the whole system. I'm trying to replicate the real world. So as much as 5, 10, 15 sound nice, that just means as long as my cups are, my volumes are divisible by 5, I have a pretty high chance of making sure I can dispense equally. I don't have to worry about over dispensing. Could I? Yes, I have 5 ounces left and I get a large. I will over dispense. But again, I like this because there's a chance that I could have 6 ounces in my bag still. And so I can serve a small, but I can't serve a medium or a large. And then it'll be left over with maybe 1 ounce or less. But I like the odd numbers. But again, it's up to you guys actually. I'll let you guys decide though. Do you like this or you want to do the 5, 10, 15?
How that works.
That works.
This works? All right.
Fine.
Thank you. Hey, I want you guys involved. It may be my dispenser, but it's you guys are learning. I get the stuff.
Hey, name my dispenser my dispenser.
There you go. I like it. So we got our dispenser. Let's give it some syrup. So we're going to do DrinkDispenser or Cliff's dispenser. Add syrup. And we're going to first do the instantiate versions. We're going to do a new syrup. And what's the name of this syrup? What's our drink name?
Purple drink.
What was it?
I said purple drink.
Purple drink. All right. Drink. And how much liquid does this bag have? In ounces.
Simple.
100.
1,000? 2,000. Then add 2 more. So everybody else, if you have other options. So this one I'm going to do the other way. I'm going to do the string name int volume. So what's the name of our drink here?
Blue drink.
All right, blue drink.
What's the difference between it with both methods you're doing? Are they doing the exact same thing, or is it a little
Yes.
bit?
But it is doing what's happening in the background is happening different. And here we are instantiating the syrup outside the class and then passing a fully instantiated item. In this one, we're sending the properties of a syrup and then the dispenser is going to instantiate the syrup. So that's the difference. And that's why I wanted to show that difference there is that you can do either way. You can have a class accept a object as it, or you can accept the properties of the object and build it yourself.
This is going straight to the syrup class.
And so what's our volume of blue drink?
600.
All right, so the blue drink comes in smaller boxes. I like it. Glad people just didn't go straight 1,000, 1,000, 1,000. I actually like differentiation because it can help make things act differently. All right, let's do one more. At least one more. All right, so which way do we want to use? The object method or the property method? Sorry, the object way or the parameter way? Object way. All right. Do syrup. What's the name of this one?
Orange.
And we're gonna do
That's
orange or
the
orange
best
drink.
soda.
So here's my question: we do orange or orange drink?
Orange drink.
Yeah, actually, let's just do orange. That way we can mess with people. We have purple drink, blue drink, and then just orange.
Just orange.
Just orange
who are like,
lines come out of
Why
it.
is this not drink?
Not crush, just orange.
Just orange.
Like soft serve orange peels just come out of the thing.
Jesus. Delicious.
I tried doing the second way and it's giving me an issue.
You probably don't have the overload.
I'm
Double check
having the
here.
problem with mine too.
Yeah. Take a look here on the drink dispenser. We have 2 add syrups. So remember, if you only kept one of them, you can only do that version of it. So if you kept this version, you can only do the second version. If you only have this one, you can only do this version.
I got you now.
Yep.
Because it kept saying new. I think maybe it's.
You
I
need to go
got
look,
it.
Junior?
No, I said I still
So,
have
but we have to overload that
just a little
second
problem.
method to add syrup.
Hold
And
on, I got Junior and Titus both talking.
If we overloaded that second add syrup method, will we still be able to do it like you're doing it? I don't
Yeah.
see it.
If you have both methods here, you can do both ways.
Okay. Gotcha.
And then Junior, what do you got?
Yeah, because mine, when I'm doing the second one, which is in the main. Yeah, when I'm doing the this.
Blue drink?
Yeah, the blue drink. Instead of name, it said new syrup.
No, again, so that's where, again, if we're doing two different ways. So we have an overload. If you double check.
So that's when you can pick up any one of them. That's fine.
Yeah, you can, if you have both of these. So again, double check your drink dispenser. If you have both add syrups, you can do either way. So when we do the new syrup, we're using this constructor over here on line 38, the add syrup, new syrup. See that? That's what the purple drink and the orange is doing. It's using this this method right here. Not constructor, sorry. It's using this method. When we do this version, the blue drink version, we are calling this method, where we send it just the name and the volume, and then we do the new syrup command inside of this drink dispenser. You see that?
Yeah.
So if you don't have this method here, you cannot do the blue drink method. You would have to do the blue drink method as the same as we do purple drink. Do we want to look at your code?
Yeah, because what I'm seeing have the same thing you have.
Right, show your code.
I don't see any difference in them for some reason.
Hey, we got multiple eyes for you.
See,
Right, so you do have the two methods.
yeah. And from here, when I put
Again,
it, give it this.
right, that's fine. But start typing. So do blue drink.
Oh no, yeah, it's okay.
And then after the, yep. That's fine.
There's
And
one problem above those two methods on this other one.
because this one's not finished yet. He has to finish
Oh,
this
okay.
to make it work. Now do a comma.
Oh,
Now it switches over. Yep.
okay.
Most likely you started typing the word new, and so it thought you were going to do the first method. But now that you finished writing out a string and putting a comma, it realizes, oh, wait, no, he's not doing the object version. He's doing the property version.
Okay.
So yeah, never let the text error stop you.
Yeah, because I was
Yeah.
like,
Property
what's going on
version is better.
I like, personally, yeah, I like the property version because it makes the code simpler on main.
Hmm.
And I don't have to type new syrup every single time. But I wanted you guys to see both because we've been using the object version before. So I wanted to show you guys that they are going to work the same, but it's a different way and possibly a nicer way of doing it
Well, the fact that you don't have to type new.
every time. Exactly, because that's
Yeah.
being now the method's handling that for you.
That's
Yeah.
very elegant.
Yep. Again, that's one of those crazy things about Java and even JavaScript too, is that idea that there are like anything you do, there's probably 5 other ways you can do the exact same thing.
Hmm.
And some of them are going to be easier and some of them are going to be more complex and like, why would you ever do it like that? But that's what's interesting about this. Why it's good to teach on certain ways. I have to sometimes teach you the less efficient way because it makes it looks nicer or it makes more sense in the beginning until you understand better and then we can move on. So that's what's good here. This made sense before because we didn't understand we could do that inside of the method. Now we can see we can, so now we can do it. Yeah, this would be the way I'd do it. That way I don't have to keep typing this each and every time. But let's add one more of the property version. So go straight to Spencer, and I'm going to add my drink.
Oh, that is.
You know what? Actually, copyright. So left. Not that they're ever going to actually come after me for copyright, but let's have fun with it. And
Is
no,
Dr. Pepper just carbonated prune juice?
if it is, then it's delicious. I don't care if it is. Saying that is going to scare me away from it. It's still delicious.
Can't drink the
I don't-
code.
Is it
I
better
don't-
than Moxie though?
I don't think I've ever had Moxie. I don't know, Moxie. I don't know what that is.
Isn't that a
Was,
cola?
It's gross. It's like a
Exactly.
gross. It's like a gross cola.
Exactly.
well, then if anyone says it's gross, then it is not like Dr. Pepper because Dr. Pepper is delicious.
Oh yeah, Dr. Pepper rules.
Exactly. Thank
Or his-
you.
Or his brother, Dr. Pip.
I think it's Mr. Pip. He didn't finish.
Yeah, it's Mr. Pip.
He didn't get his doctorate. That's
He
right.
dropped out. It was too hard.
He was spending too much time hanging out with Admiral Nelson.
No, isn't that the joke on American Dad? He's a everyday man. He doesn't have any pretentious titles like some other drinks.
That sounds like Seth MacFarlane humor.
Yep. All right, so we got our syrups. Let's go ahead and serve ourselves a drink, which we didn't actually finish, by the way. I just realized. But
Well.
fine. We'll drink. We'll get ourselves a nice medium, and then we have 0, 1, 2, 3. Which drink do we want?
3.
We're drinking some orange. All right, we'll drink some orange first. Let's just see if the code
Oh, you
runs.
said it was 0, 1, 2, 3.
Yeah, 0, 1, 2, 3. So that's why. Oh yeah, we got some
Oh,
Dr. Cliff.
3
You're
would
right.
be- okay.
Thank you. Totally said that wrong. So yeah, we're getting some
I
Dr.
know
Cliff.
you were just
Nice.
testing us, Cliff.
Totally testing. 100%. Let's just see if this runs. It's not going to display anything because we don't have any system outs. Let's see if it runs. That's the first key item of anything we do with code. Does it at least run and not fail?
Yes.
Hey, look at that. No errors. Woo.
Oh, my potato processor's on fire. Give me a second.
Oh, yeah, sorry, Matt.
Fry an egg on this thing.
10 minutes later.
No, invalid size. What?
No, it's size.
I
Oh,
got an error. This syrup is no.
be aware that it's case sensitive.
It is case sensitive. That'll
Yes,
do it.
strings are case sensitive. So if you have a small m in here, but big M in your code, it will not match. It is
Add
case sensitive.
Company drink dispenser add syrup. I got an error.
I wonder if this will
Cannot invoke Java util list object because this syrup is null. What?
Share your screen.
What?
I'm not sure that did not make sense when you said it. I'm like, I don't know what he just said.
Hold up. Let
I
me just
fixed
share
it.
the other screen. Other screen. Other screen.
If you change the switch case to size.to lowercase locale root, it'll fix your case problems.
Yes, that's something we would deal with later. I was going to deal with case sensitivity and error checking later. In the beginning, always act like your inputs are going to be from a perfect source. You can always add error checking in, user error catching later.
If I knew enough about the code that I just wrote to make sure that I put in perfect cases every time, I would do that. But as soon as I find an error because I create my own problems, I fix it on the fly.
All right, so let's see what we got here. Cannot invoke the add method. So this dot syrups is null. That means your add syrup isn't working to me in my mind, from what it's telling me. Syrups not add new syrup, syrups not add.
Maybe
no,
my-
oh wait, right, we didn't do the new array list, most likely, because it's saying that syrups is null. So scroll up, let's see syrups. I see it. Anyone see what he did?
Is it the commented out
Yep.
on 11?
Yep.
Line 5.
Oh,
Well, either one, either a line 11 needs to be uncommented or that new array list needs to be added to line 5. So you have two options here, either uncomment 11 or add the equals new array list to line 5, which is what we have. Yep. There it is. Yeah, your syrups was null. It wasn't an instantiated list yet.
Yeah.
Good. It runs, no errors. Anybody else? All right, let's go back. All we need to now, though, is add to our serve drink method. We now have to actually display what we did. And so we know what is, so dispense, what does that give us again? Let's go back over here. What does the dispense method give us? Wait, was it not that? Not what I intended to do. So we do, yeah, dispense on syrup. So we go syrup. We look at dispense. What does dispense give us?
The name of the syrup that was dispensed.
Yeah, name of the drink, right? Yeah. And what we want to do is we want to return our output. Let's do this. Output should be size. Size and drink, right? So I'm going to do return. Let's do, oh, not return. Let's see. We have a void. So do we just want to display it? Do we want serve drink to display it? Or do we want to return a string with what we did? What do you guys want to do?
Display it.
Just display. S out. I'm actually going to change this to print F so we can take advantage of that formatting. So we can make it look like this almost, maybe. Oh, maybe not. I'm not sure yet. Let's do it, just so you guys can see this. I know some of you have seen it, some of you haven't. So this one will do %s space %s. This we're just going to do size, comma, this. I need to access that. What should I do with it?
Save it to a local variable.
I can do that. Drink. I do size, drink. And that way, this kind of matches what this says, right?
Was it %s twice, Cliff?
It's two placeholders, %string, %string. So this S becomes size, and this S becomes drink. So that's the printf system. The S out, print line would be size plus space plus drink. That would be the concatenation version of it.
Where are you getting drink from?
Oh, we just instantiated it here. Sorry.
Oh, okay.
Sorry.
I need
Yeah.
I need 1 second to copy that in.
Yeah. We needed to save the output of dispense. We weren't saving that yet. So we were dispensing it, getting the name, and then just chucking it over our shoulder or just dropping it on the floor. So we're getting our cup of Dr. Cliff and we're just dropping it, which would be a very sad day. Don't drop your drinks.
Just to let you know, when you do S out, if you change the T to an F, it'll do the formatting print automatically.
ST?
SOUF.
I only have to do SO to get this one. So yeah, SOUF will get you this guy.
Yeah. Yeah.
Nice.
It's really SOU S out. It will give you the whole thing, but I guess if you do SO, it'll.
Yeah, I just do SO when I get S out. That if I do S, yes, I do have to do F. SOUT gets us the print line. Cool, interesting. But these are the two different ways we do it. This is the way we've been doing it, and just so you can see it, this is the way to get the other version of it. So this is the formatted version. We do placeholders instead. So %s for strings, %d for digits or for numbers, in other words. I think they do have %i for integers specifically.
Yeah,
I know
and %ds do decimals or floaters and floating,
Decimal floats, right,
and
so,
FQ also.
So yeah, %s for strings, %i's for integers, %n, d's for
actually-
doubles. What's that?
D does integers for digits, and F does floats for doubles and floats and things like that. Just wanted to point this out also, if you're using the printf, it does not do a carriage return, so you have to do the \n to get your next return because it'll just string it all along. So
yep.
I
was actually going to have it. I was actually going to show that with the output, but it's fine. You already said it.
But yeah, no, I just wanted to point it out.
Yeah, you guys know how print line automatically moves your cursor to the next line, so you get multiple lines of code. Every time you do the print line, it automatically moves to the next line. Print F and print don't do that. Only print line adds that carriage return there. So do be aware of that in your code. Print line automatically moves your cursor to the next line, whereas print F and print do not do that.
I'm a little confused by that.
Yeah.
Okay, let me show you it. So
please.
Let's do a quick one. Let's go back to main quick. I'm just going to do this quick. So we'll see how this stuff looks different. So we got the print line, hello world. We got the print size, size drink, drink size.
Mhm.
You see what happens?
Oh,
So hello world, two different lines. So the print line automatically adds a /n right here. So there's a /n here that you do not see at the end of this. So it automatically adds that /n, that new line character. Printf, as you can see, does not. So when I finished my first printf, there was no space here, there's no new line. So that next %s right here was tacked on immediately after.
wow,
The
okay.
cursor stayed right here after it ran, so that the next time I hit a printf or even a print line, it would do the same thing. So even if I switch this now to do ln and just do the drink, yeah, just print the drink, you'll see that that orange shows up a second time, but now it will go to the next line. So if I do another S out size here, the size will be on the other line.
Oh,
That work?
yeah, okay.
So that's the difference between your printf and print line. Print line automatically gets you a /n. Printf, you have to put it in there.
Is it a good practice to put it in there on a printf, just so that you don't create confusion later on?
9 times out of 10, yes.
Yeah.
Yep, 9 times out
what
of
I
10, you
figured.
should add the new line. Yep.
What's kind of good is that when you're doing a printf, you could do like /n/n/n, so you can actually add like three like character returns after it. If you're trying to space
Yeah.
things out, you can work it a little bit better than
Yeah.
print ln's like empty ones, and then
Yeah.
it just kind of takes up more code.
Yep.
Okay.
And again, like I said, there's multiple ways to do the same thing. So, yep, there are points where the printf will give you more power and give you what you want. There are other times where print ln will make your life a little easier. So, just know this is you having multiple screwdrivers in your tool belt.
Right.
They're all going to work, but sometimes certain ones will work better in certain situations. So, I actually, I go more with a hammer. That's a better item. It's like having multiple hammers in there. No matter what you're trying to do, you have a hammer, you'll most likely be able to do it. But just sometimes the sledgehammer in your tool belt is going to be much better for taking down the wall than the normal hammer. Can you take down the wall with a normal hammer? Yes. You can definitely take down the wall with a normal hammer. But is the sledgehammer going to work better? 100%, right?
Mm-hmm.
It's kind of the idea here. Print line and printf both do the same thing, but in certain situations, one's going to do it better than the other. So we're going to go ahead and comment that one out. We're going to let's comment out the print line. Use printf for this just to see what it looks like, see how that works. Back to our main, and let's uncomment this stuff. And let's see if our dispense now works. We got a medium Dr. Cliff. For the real test though, dispenser dot get dot get what is it? Syrups dot get 3 dot get bell. I want to make sure we did use that liquid, right? So what I'm doing here is I want to see, did I actually use the liquid? I also want to do dispenser dot medium dot quantity. Oh, I also need a system out these. Let's do this actually. SFF. Dang it. Soof. We'll do %I. Oh no, %T. %T. This. And cups. Ups. I'm gonna do a /T. Does anyone know what /T does?
Tabs, right?
Yeah, tabs. Yep. Good. Do that. I'm gonna do that and I don't need to do this one. I can do that one line now, and also add that /n there. There we go. I don't know what just happened. Hold on. There we go. Let's see. Go over to that. I'll make that a little bigger so you guys can see what I'm doing. So if you want to add the same code yourself, you can. So I'm doing that, I'm printing out the quantity of our medium cups and the volume to show that we have a full set. This is going to show us the full volume. And then after I dispense a medium cup of drink 3, I'm going to print out that item again. I'm going to print out the quantity of medium cups and the volume of our syrup. We should see 8 go down from our volume and 1 cup go from our quantity, right? So this will show us that we actually did use it, because yeah, it's great. We could always just lie and say, yeah, we got a medium Dr. Cliff. This is going to tell us, yeah, we actually did get one. We used the liquid and we used the cup. We didn't just pour the cup onto the floor or pour the liquid on the floor. We didn't just get an empty cup. Let's see. Oh, I forgot to refill my cups. Let's see. I don't know if anyone heard me there. Let's everybody run it and see the problem. What everybody get?
I'm still catching up.
No worries. This is the time to do it. Put someone down for a minute. I know that system app print app that I just added is a bit of a mouthful, so.
So Cliff, why is it a percentage D instead of a percentage S in this situation?
So what are we printing? What data type? What is quantity and what is vol?
Oh, are they
Ents.
double? Oh, there
No, in the format F, it's a little misleading.
A
D
digit?
stands for digit. Yeah, not for double.
Yeah.
So that's why I actually, that's part of the reason why I tend to not really use printf that often, because I actually hate that it uses %D instead of %I for integers. It's a bit misleading, but I did get used to it with when I did the C language, because the C language uses this, uses placeholder systems. So
I actually have to head off for the night.
yep,
I
I'm
will.
recording.
Yeah, I will catch up with the video. Enjoy your vacation, guys. I'm sure we'll see you. I'm sure I'll see you rather at some point during the week.
Have a good
Yeah,
one.
definitely. Have a good one, Matt.
See you, Matt.
You guys.
Yeah, man.
Hey, Matt.
See you, Matt.
Okay, yeah, I have the same output that you have.
All right. Anybody else need more time?
Yes, I do.
Well, he could just type though. Does anyone see what happened to our drink?
Hey, you didn't refill the cups.
So what happened to
Someone
it?
stole a cup.
I don't know if they stole a cup, but what happened to my liquid? It dispensed, right? So I did dispense it. But where did it get dispensed? Wasn't a cup, right? So where did it get dispensed?
On the ground.
Into that little
To a
tray
negative
that catches things.
I hope we have that tray. Yes.
So should we put a fixed amount of cups?
Well, that was it. We either need to, when so for the constructor we didn't set a default amount. So what I need to do is after I instantiate the dispenser, which I want to wait to do it, we just need to refill our system. But let's wait for everybody else to catch up to here first. Because we have a refill method. Remember, our cup holder has a refill method that we're not using yet.
You also have no cups. Now you have a -1.
Well, again, yeah, that's the thing. Our system
pretty
does
stuck
not
on
have a way of knowing whether or not it has a cup, and whether it gets a cup or not, it doesn't care. It's gonna run this. It's gonna run the spinners. It's gonna spit out a cup, or it thinks it does, and it's gonna drop that liquid, whether the cup there or not. So we better hope we have one of those catch trays. Because if we're not, it's hitting the floor. I just wasted 8 ounces of Dr. Cliff. No.
Can I share, please?
All I do is just push the button and
Oh, yes,
it
definitely.
dispense the water, the drink.
Yep.
And you
Go ahead,
just
Junior.
put your mouth right under there.
I probably would have. I would have been right under there, like, no, don't waste it.
I don't know if because I'm tired, I'm getting some yelling here somewhere.
Oh, you're doing. Everyone see what the problem is? I see it.
I'm getting.
It's right. It's on this. It's on this page. Don't worry. Your problem is here.
Yeah.
It's a very subtle one. It might be easy to miss because.
Is it on
instead of
line
print outline,
15?
It should be print F.
Hey, you went to print line.
Is it?
Oh, yeah.
Be print
Yeah.
F instead of print outline.
Yeah. What you typed were the print F code, but you're using print line. So what you're doing inside of the parentheses is the print F format. We're using print line. So you want to do print F. Dot print F. There's a lot of print options. Trust me, you just type it. Just type print F, yeah.
I was like, where's this? Where-
Yeah. There are a lot of print options. That's not going to be easier, unfortunately. There you go.
I also gotta work in the morning, but I'll be on the lookout for that YouTube video.
Yep, I'll try to get that up as quickly as I can.
Appreciate it. See you all. Have a great
Good
night.
night. Good night, Sergio.
Have a good night.
Yeah.
And
Yeah.
I have a yelling here too on the drink thing.
Oh, you get yelled at for that. That's fine.
But I thought-
Because
I
you
thought
gotta
was
assign it.
another.
And that's fine.
Syrup.
You didn't sign drink to anything.
Yeah.
Yeah,
You missed the-
37.
You need to assign it.
Sorry, you missed when we did it. On line 37, that's where we get our drink. And so we just had to create the drink variable. So we did string drink equal
Oh, here.
on line 37.
So that's 37. Yeah.
Remember, the dispense method returns the drink name.
Mhm.
So we need to
So-
catch that in a variable.
Still leave this one here.
Yep, leave that there. Yep, that's going to give us the drink. We just need to save that in a variable so we can use it on line 42.
It's gonna be all on the same line.
Hold on, Mike. Let him type. It's fine. What he's doing is not necessarily wrong yet, so he's waiting for people to do it. We don't want to get too crazy. Now, what are we putting in the drink? So again, what does the dispense method on line 38 give us?
The drink name.
Yeah, so we want that line 38 on the same line as 37, right? So that way that dispense gets put into drink, right?
Yeah. Also,
Technically, this will work. Actually, the way you have it typed will work because Java doesn't care about new lines. But it looks better to have line 38 on line 37.
So that's me just put a new line here.
Nope, just hit the delete key once.
Oh,
Nope, that's backspace. I said delete. Unless you're on a Mac, then no, you're on a Windows. Yeah, you have a delete
on
key.
Windows.
DEL. Yeah, you have a delete key. DEL. Unless you're on a laptop, then maybe not.
Yeah, he's on the laptop.
Dang it. Oh wait, there it goes. That's what we want. But get rid of the extra white space.
Oh, okay. So it should.
Yeah. Because again, we're taking that result, the result of dispense, which is our drink, and we're going to store it in the drink variable. Why is that still
40
yelling at you?
48, you just have to change the print statement to F.
Oh, yeah, print F again. Yeah, same thing. 48.
Point that out again.
Go ahead, Jim.
Line 48, change the print name to F.
I think that's line 40.
40, yeah.
Yeah, it's
Oh,
line
hard to
40?
see.
Oh, it looked like an 8, sorry.
Oh,
Oh.
yeah, yeah.
That looks like an
Because
eight.
I was
Sorry about
like, what's going on?
I didn't even notice that he was saying the wrong number. My bad.
Yeah, it looked like an 8 to me.
But now, Junior, take a look for a second. You see the difference between the print F and the print line, right?
Yeah.
So print F has those percent signs and multiple items, whereas print line does plus symbols to concatenate strings together. It only takes one string though. Whereas print F takes one string and multiple variables, print line takes a single string, but you can combine multiple strings into one string.
Okay.
All right.
Thank
I think you're good now. Let's try running it.
Yep.
That looks good. We're missing the space on line 41, but otherwise good.
So it's
His
weird.
volume went up though.
Yeah,
Yeah,
volume went up.
Oh, wait, I just noticed that. Yeah, you're right, it did. What? How'd that happen?
What
We'd have to
did-
look at the dispense cut method. We could do that in a second, though. Before we do that, let's go down a little bit. Yeah, you're right. We'll go down a little bit on line 41 inside the two double quotes. You need a space. That's why you have MDR Cliff instead of M space Dr. Cliff on your printout. See that?
Yeah.
Yeah. And then really, honestly, you only need to keep one of those two printouts, either 41 or 40. You don't need both. Pick which one you want to keep.
41 or 40.
Yeah. Comment the other one out.
Yeah, let's just do that for me.
There you go. Cool. Now let's go ahead and so scroll up a little bit. So when do we do that? What item removes value or is supposed to remove the value from the item? Or scroll down you went too far up. I want to look at all of serve drink. I'm just trying to get the whole serve drink method in view. I don't know if we can actually. Keep scrolling down a little. Right here. This is enough. I'm trying to get as much of the method in there. So where are we supposed to be reducing the volume of our syrup? Which method does that?
String dispenser gets you this one.
Yeah.
One of this
Well, the dispense, right? Dispense is going to reduce our liquid, right? Yeah, so you're right. Yeah, right there. So let's head over to the syrup class because that's what the dispense method is defined, right?
Mhm.
Let's take a look at dispense. Are we reducing or are we incrementing?
Incrementing.
We don't want that, huh? We're using the liquid, so we should be reducing, shouldn't we?
Yeah.
All right, switch it.
Oh, let's do that.
There it is. Try running again. Good catch, by the way, people. I did not see that go up. I totally missed that. There it is. That looks good. And again, just like me, you are losing a cup and you're dispensing liquid on the floor or in your catcher. Which if we're dispensing 8 ounces into our catcher, it might overflow, fill a little. No matter what, it's definitely splashing. All right.
Thank you.
I'll go ahead and take back over. There we go. Not that. All right, and so to fix that little cup thing, we just want to refill. We just want to fill up or refill our dispensers, our cup holders. So, can anyone tell me what the code is to refill my cup holders? I wouldn't give an idea of what I might want to type for that. Pull this back over so you can see the drink dispenser class. Any ideas what I should need to type for that?
Cliff's dispenser. Dot. And we're just doing it for medium since that's what we're using, right?
We can, yeah, that's fine for now.
Dot refill, I think it's called.
Cool. Yeah. How many cups do we want to give?
Let's do 15.
15 cups. Let's try it out. Hey, that looks better. We have a cup now. So you actually dispensed our medium Dr. Cliff into a medium cup and got a drink. Delicious. For the fun of it, let's go ahead. I'm going to go ahead and refill the other two now, just so we have them. 15 in each. Actually, we'll do 20 small because those come more bundled together. And what's dispenser dot large refill, and they come in 12, pack of 12, because they're going to take a little more space. They don't fit in the box as well. Sound good? Got those. All right. Let's go ahead and do the low syrup one quick so you can see how that looks like. What time is it, by the way? Oh, wow,
So-
1:30. Damn.
So for this, are you going to be returning an array? Because it is
Yes.
going to be like multiple.
Yeah, we want multiple indexes. So if we want to return a collection of indexes, whenever we say we want to return multiple of something, a good rule of thumb for your mind would be to say, oh, if I'm returning more than one, that's a collection, right? And so we could do an array or a list, right? We just need some sort of multiple. So what should we return?
Let's do an array of type int.
So we could do an array. Do we know how big our array should be? We're gonna end up building?
No, we do not.
You can do a list, by the way, as a return type. List of indexes. our indexes are integers, so we can do a list of integers. Low syrups. And what's the value we consider low? Well, okay, right, we can just accept any, right? Hold on. Int low value. So I'm going to accept a number that says this is our low value, right? Or I could have made this a little easier by actually just giving you a static value, but I didn't know what you guys were going to do for your number, so I didn't want to do that. I didn't know how to do that. Anyway, it's fine. All right, so we need to go through our system. We need to go through the syrups, check their value against our low value. If our value is less than or equal to our low value, we want to add that to our list. So what's the first thing we need?
Well, a max value.
Max value. What's our max value? If you remember correctly, the three items we entered are all different volumes starting.
I would think you would want to go through the list. You would want to like loop through the list.
We do want to look through the list. Is that our first thing we want to do? Yeah, let's do that first. So let's do 4. Now, is it 4 in or 4 each? A 4 in or a for loop? What do we think is the best here?
It depends if you want to create a variable to keep track of the index. You can do a for each. If not, just do a for loop.
Very good point. Very good point. Yeah, we need the index, right? And a for in doesn't give us an index, does it? And so in that case, if we want to use the for in, we'd have to do our own index counter and have to manage it ourselves. Whereas the for loop has an index variable managed for us. So we're going to do int I equals 0, I less than syrups dot size. Remember, size for lists. Don't forget that. Plus. All right. We're now going to check for if our, and this is our condition now. Now we need to check for if a syrup is low. Well, first, how do I know the volume of this syrup? How do I get that?
I think it's syrup dot get volume. Is that what you called it? Okay. Oh, sorry. Syrups with an index of I.
Syrups get I, right?
Yeah,
We got to get the item out of the list first. Now we can do get val, and that's going to get us the volume of our syrup. And if that is less than or equal to our low val, our syrup is low, right? So what do we want to do next?
Do you want to replace it immediately, or are we just saying that it's empty?
You want to add that to the list that you're going to return.
Oh yeah, sorry.
All right, there we go. Joe's getting fancy here. It's like we got a system that automatically replaces syrup now.
No, I'm like half paying attention because I'm looking at the changes as you go.
No worries. So Mike, yeah, you're right on that. We need to add it to a list, but where do I have anything I can add it to? Yep. So what was the first thing we actually needed?
Create a new list.
Yeah. Lows, I guess we could say, or R low. We can put output. There's multiple different options you can have here. Also need to do integer. Got that. What do we like? Output, lows, R low. What do we like?
Output is fine.
We'll do that. List. Now we can do output add I. Look good?
Then we just need to return it after the loop.
Hold on 1 second while I jot this down.
Take a second, yeah.
Would this be considered an embedded list? The output list?
This one?
Yeah, would that be considered an embedded list?
Sounds like, yeah. More or less, I would just call this a list variable. This would just be called a variable. This is a variable. So it's just a list that is scoped to the method. So this is what you would call a variable, right? Method variable. So kind of harkening back to like, I think one of the first questions of the class, that Keith brought up, which is great again. Yeah. Fields, that's these lists. These lists up here are fields. Where are they? This list right here is a field, where this list is your method variable. A variable that exists only in a method and only exists when the method is running. As soon as the method ends, it dies.
In my notes, I have it called as a local variable. That's okay, right?
That's another way of putting it. It's a local variable local to the method. Yep.
And why is that last parentheses yelling at you? Because mine is doing the same thing.
Yeah, me
Any
too.
ideas?
Not returning anything yet.
No return. There's no return statement.
Yep. Hover over it. Yep.
Yeah.
Remember, our low syrup method requires us to return an integer list. We're not doing that yet. So it's telling us this method is not finished yet. So what do we need to return, people? After the loop is finished, what are we returning?
Output.
Our integer array, our integer list of all of our low items. So let's test this next. We go back to main. A moment, I'm going to go ahead and do list this s out. Sorry. Dispenser dot syrups, and I'm going to say 100 as our low value. So if we go below 100 value, we want to print it. Are we going to get a printout?
No.
Nope. Let's make sure. We should get an empty array. Good, nothing's low. What I'm going to do next is I'm going to force this thing to go low. So I'm going to say we have 100. I'm going to have 105 as our value. One drink is going to put us at what? One medium is going to put us where? Let's do this.
27.
Hold on. Let's do 12 actually. Yeah. So one drink isn't going to do enough, right? But if I do another one of size large, that should put us underneath, right? That should put us low, right?
Yes.
Let's see. What is that, Des?
I'm sorry.
All good. You see, we got medium cups 15, 14. We got our medium drink. Nothing's low yet. We then serve another large Dr. Cliff, and we now have our Dr. Cliff marked as being low. It needs replacement.
Is
Seems
that
we're
the
working,
output
right?
that you wanted, Cliff? Did you want the number or did you want the actual name of the drink?
That would require more. Yeah, if we wanted that, we would have to require more on that. Right now, we're just getting that. So what we could do though, let's see. Could we switch this? Instead of doing a list of integers, let's do this as a list of strings instead. And so instead of adding I, what would I add instead?
Dot get I.
Not enough. That's going to get me the whole syrup object. What else do I need?
Get name.
We don't need get because it's a public item. We just need name. Its name is public. We could just do .name. Let's see if that looks better. Good question there. Look at that. Much nicer, right?
Good stuff.
But I was imagining that you wanted the indexes so that whenever you want to replace them, you just use the indexes instead of the name.
That makes sense to me too, Joe.
Yeah. I just wanted to show that this was a quick change, but yes, that was why I wanted the low syrups to return the indexes for two reasons. One, yes, we could just use that number during the replace syrup method later on for the extra challenge, but also just think of it, if you go to the back system, you probably have each box at a certain number, right?
Right.
And you might not, you probably could be the box, but not necessarily. So we could say, oh, the box at position 3 needs to be replaced. We just go there, replace the box at 3 and put it with the new box there. It might help to know what the flavor is so that you know what flavor replacing, but either way, again, there's multiple arguments to which one is going to be best, and it really depends on how your implementation of the drink dispenser at your establishment, right? So something to think about. If we kept string, we could always do this as well. We do I plus so now we can get the index and the name. So that could be useful. So now we know the index and the flavor that was there. So when we go back to replace it, we know that we're going to get the box at position 3, and we're going to replace it with another Dr. Cliff.
Even better.
Right.
A map would have been better.
No, they that's getting fancy. We're gonna get into maps next when we get back. So don't worry. Maps are a little fancier item, but we will get to those. Especially because they actually use something called a hash map in the system. They don't use maps. They're called hash maps in Java. But we'll get into that when we get back from break. Those are a little more advanced. So we're probably gonna do Yahtzee first and then get into that stuff. But those are getting into those because those are getting into data structures. So
I know we've used them in HackerRank if you've gotten
Oh, yeah.
to a certain point.
Yep. You'll learn about those in HackerRank 100%. So yeah, there's our low item. So we'll go ahead and keep this version of it. This is kind of cool. Having the string actually.
Wait, hold on, keep it. I'm just
trying to think.
Mine's just yelling at me, but I'm just trying to like self do it.
I was trying to think. Should we switch back to the in-text? Because that's what the. I don't know. I'm gonna keep it like this because this actually looks nicer, and that way you guys can still try to do the index version for your versions later on the weekend.
Can I share one more time? Because just
Of
that
course.
when we switched it, it yelled at
Go
me.
for it.
So when I hover over, right, it says
Because you kept it as integer.
Oh yeah, we did. We switched it to list string. Yep. One more spot.
so
Look around. Your output is a list string. What's the return type of the method?
wouldn't it be a string? If
No, look at it. Don't tell me what it is. Look at it. What is your system currently saying?
Where did you
What is the-
declare what you're returning?
That's what you're returning, but in your current returning output, which is a list of strings. But what is low syrups expecting to return?
A value,
Again, you define it somewhere and look at your code.
an integer.
Where do you tell your system what a method is going to return?
So would it be an int? If we're telling it we're returning our low value,
That's not the return type though, is it? That's the parameter.
it's a parameter. So
Where's the return type?
um,
I think my last hint for you is going to be it's line 48.
yeah, so it's an integer.
Is it?
It'd be this. We're returning a list of integers.
But we're not anymore. We're returning what? We're returning a list of what?
So then why do we keep? Would I have to change this as well?
Yes. Yep. There you go. Yep. We changed what output was, which no longer satisfied the return type, which means we need to return the return type too. So that the return
Why
type
did-
will actually match.
Why, now, what was the? I was like, catch. Why did we change it from a integer into a string? Was that
Readability. We realized that it would be nice to have the integer, the index, and the flavor, not just the index. Display.
I got you.
So
I got
we can
you.
display this instead of just the number. So, yep. Mostly just because the students, there was some nice recommendations of saying, hey, you know what? It might be nicer to show the person the flavor instead of just the index. That might not be useful. So like, let's do both. We'll show the index and the flavor. So we switched it to string, so we can do both. All right. Let's see. We're at 8:9:4. Shot system. Can we do the shot system quick, or is that going to take a little long? And do we want to do that? Have you guys attempt the shot system over the week, during the week, actually? Yeah. Let's do that, actually. I like that idea myself. Let's do that. We're going to go ahead and have the shot system be the homework for the weekend. Adding the shot system to your drink dispenser system. It's very, very similar to the drinks with just slight variations, only very minute variations. This will also open up some extra time for anyone who wanted to take on the extra challenges but didn't have the time for it. You can still try them. And then on Monday, that'll be what we will review. We will do the shot system together, and I will show off the extra challenge items. So you guys are gonna get a full week. On top of that, what I'm also giving you guys is access to a tutorial known as Mosh. So this is a video system of Java. It's going to go into more details. It's definitely going to be a lot more lecture based with some examples, of course. But this is going to give you a little bit more. It might even dig a little deeper into some of the topics we touched based on, so that we can also dig deeper into those as well in class. So I'm going to assign those as well for the week. You're only required to go through the intro level. I think that can be done within the week. I'm pretty sure it's not that long. I think you guys can actually, if you take the time, I'm going to double check again how long it is. But I want to say it's like less, I think it's less than 20 hours total. So I think it can be done in a week. I actually think it's less than, I think it's like 10 hours. I want to say maybe less. But I think the intro videos, so there's three tiers: intro, intermediate, and advanced. Advanced really isn't needed in his lectures, but it's there for you, those who want it. Only really beginner and intermediate is what you guys need to go through to get the items you need before we move on to Bootstrap. I'm not Bootstrap, Spring Boot. So that'll be the homework for the weekend. Go through the intro section of Mosh. Now, like I said, you guys can do watch parties. Set them up once over the week. Set up sometimes we'll watch the videos together and then review and ask each other questions after you guys watch them. It's something I like to do with some of my classmates. When I was during my study sessions, I'd be like, hey, the class is here. If you guys want to talk about this video, come to the study session on Saturday. So we didn't watch it together, but I did say those who come, we're going to be discussing the video this day. That's the goal of this study session. So definitely feel free to do those. Again, if you guys want to work on this as a class as well, anytime next week, set it up.
When are you going to be giving the Mosh videos out? Then tonight? Or?
I'm gonna put it in the classroom tonight. I just gotta find the credentials again, because what we've been doing before, we were using
one you gave up.
Yeah, the one you already had, Titus. Yep.
Yeah, that's all. I'll go through it again. That's perfect.
Yeah. So I'll be giving those. So here's the so yeah, you have the shot system. So you have the shot system for this. Okay, we're try to put that in here. The extra challenges. You have the Mosh videos to watch. And then if anyone does seem to finish those items and get them done, I do have additionals that I can give out. So anyone wants to get a little ahead on things, definitely be sure to reach out to me, check with me on that. So you can get a little ahead. What's that?
Those Mosh videos are total. I just did them all. It's the same ones you gave us.
Yep.
Total is 13 and a half hours for all three of the fundamentals, object-oriented programming, advanced topics.
All right. So 2 hours a day, you could do it if you miss 2 days, but all right. We'll say, yeah. So we'll say you have to be done with them in 2 weeks, maybe 3 weeks, but try to get as much as you can. If this group can get them done in the 1 week, awesome. But it's a bit, I feel a little difficult. It feels a little evil trying to say put 2 hours in every day during the July 4th break. But again, that's if you guys want to keep moving forward. See if you can pull it off. If you can pull it off, great. If not, it's fine. So yeah, we'll try to do 2 to 3 weeks for Mosh to be able to watch all 13 hours. Thanks for that, Jim. Yeah, can be done, but I'm not going to force anybody. Take your time to make sure you understand it. That's the main reason why I'm not doing it. I'm taking it away that it has to be done in 1 week because I want to make sure everyone can take the time to understand it. I don't want anyone feeling like they're being rushed to the videos. So we'll give you guys 3 weeks on that then instead of 1. We'll do 3 weeks since, yeah, that'll give you guys the ability to do half an hour to 45 minutes for 2 weeks. Yeah, then you can watch the whole thing. Get an hour per day for 2 weeks. Then you have an extra week to kind of recover anything else you need. And again, I may even add a little more time, but minimum, yeah. Minimum, if you can get it done in 3 weeks, that'd be best as the maximum time. I think everyone here can do it in 2 weeks and definitely think it's possible to do in 1, but main goal is to understand it and comprehend it. So if you need the extra time to make sure you comprehend it, take it. Do not push yourself, not rush yourself. Push yourself, but don't rush yourself. That's a better way of saying yes. Yes, push, but don't rush. Make sense? Yeah, you understand the difference? So we want to push, we don't want to rush. We don't want to burn out. So And we want to make sure we do actually learn the information in the videos. That's key.
I
So
think
don't rush
this,
it.
I think mixing some of this Mosh stuff and then like something like when he gets into doing hash maps or something, you can mix it with HackerRank because they have like hash map like algorithms to like try out or something.
Yep, which I was gonna say, and yeah, if you guys ever need to take a step away from Mosh or just feel like, you know what, the videos are getting a little brain fried from watching videos, take on a HackerRank challenge, go back to one of your previous exercises and try to touch it up a bit. You have the free code camp algorithms you can use as trials and things that you can play with, and really just even just code along with, just do a peer programming session with a classmate. There's ways you can code that are less intense sometimes, so make sure you take advantage of those items where you can still put yourself in the environment without overloading yourself. Make sense? Main thing is just being.
All right,
making
I
sure
gotta
that you're
get going. Have a good night, everybody.
Here you go, Mike. You're good.
Yeah.
The main thing is just keeping yourself absorbed in the code. That's the key focus. Stay surrounded by it. Stay working on it. And again, I already had my vacation, so I'm going to be fully in front of my computer this entire break. If you guys are holding meetings, I'll probably join in some of them, kind of help out, answer questions. If at any time you're stuck on anything, either in Mosh videos or in the dispenser program, dispenser exercise, reach out, ask questions. You can at me at any time and I'll at the channel. So feel free to do that anytime. You can also even at me and Gabe, and both of us, whoever's free, will jump in and do an at channel if we need to get you some help. So we're here to help you guys. We're here with you the whole step of the way until you guys all understand it. Every single one of you. All right.
Awesome.
All right, cool. Have at it. Take a stab at it. Keep working on this. We got it. You guys are progressing. Yeah. I'll see everyone on, don't know what day it is actually. What day number is it? What number? It is the 12th. I see everybody on the 12th. Definitely. I'll probably see a lot of you earlier because like I said, if one of you guys are holding a meeting, I'll probably jump in, but I'll definitely see everybody on the 12th.
Yeah, I might.
Take care. Yeah, reach out to me if you need some help anytime.
Thank you.
All right, I'll see y'all then.
Good
Take
night,
care.
everyone.
Yeah. Night.
Good night.
Have a good night.
Come back in. Oh, I didn't hit that yet. I gotta do the